Hi, good morning. This is Purnima Mahalingam, and you're watching the lecture series on power system protection switchgears. Come, let's go into the video. Today, in this video, we are going to discuss about nature and causes of faults. So, in last class, we have discussed the basic protective schemes and what are the needs for protective schemes, etc. So, today in this class, we are going to discuss about what are the nature and what are the causes of faults. Here, first thing we are going to discuss about what are nature and causes of the faults. So first and foremost important thing is insulation failures. Here we can see in these pictures, even the insulated get failures, the faults may occur. This is the main thing. The next one is conduction path failures. Because of the conduction path, it gets any failures, there'll be forming of faults. The percentage of forming of faults would be high. And the next one is the over voltage due to lightning or switching surges. As we can see, the lightning or switching surges because of the switching from one circuit another circuit. Because of that, we'll be producing over voltages, or because of lightning of over voltage, lightning will be getting the over voltages. Because of that, it may causes the faults. This is the nature by the nature and by switching. Okay, then next is punching and or breaking of insulators, and failure of conducting path due to broken conductors, and failure of solid insulations due to aging or heat or moistures. So solid insulation, here we can, in these pictures, we can see the insulation failures, the aging, and moisture and heating, whatever happens, and we'll be having the over voltages. And this, because of this over voltage, the accident contact with the earth or earth screen and flash over voltages, these are the main causes of fault occurs. What are the fault occurs? Because of these main causes, the fault may occurs. Okay, next one is fault type. We have an major fault type. One is a shunt fault type. Here, what about shunt fault type? We have seen the three-phase line. We have seen this three-phase line. Here we have three-phase line. What is this is a three-phase fault. If the fault in three phases also, we can see the three-phase fault, and we have a line-to-line fault, and we have a line-to-ground fault, and we have two-line ground fault. So we have a balanced and unbalanced condition. We have the three phases are balanced, and here we have a three phases and unbalanced. See, the phase one phase is getting increases, another phase is getting decreases, and this is an unbalanced fault conditions. And here we have a balanced fault, and we have a three-phase fault, line-to-line fault, and line-to-ground fault, and line-to-ground, two line-to-ground fault. These are the things. And the next thing is here we are seeing another number fault. This is already we have seen. Here we can see what type of fault it is. Short circuit calculation. We have seen the short circuit calculation. These are the fault type. This is single phase to ground fault. Here we can see this ground. Here we have a single phase, phase A, single phase to ground fault. This is a single phase to ground fault. Here we can see line to line fault. Here we can see phase line. This is phase B, and this is phase C. We have seen the fault between the phase B and phase C, the line to line fault, and we have seen the fault, three-phase fault. We'll be having seen the three phases, a phase A, and this is phase B, and this is a phase C. We have fault in all the three phases. So the fault may occurs in whatever type, it can occurs in single phase to ground, it can occurs line to line, and may occurs three-phase fault. And next is symmetrical fault. We have seen it is symmetrical fault. There is a three-phase fault. Here we have seen the three phases we have fault, and the three-phase earth fault. Here we can see the three-phase, but the fault earth also earthing the fault. The symmetrical fault. Unsymmetrical fault, phase-to-phase fault. We have seen phase-to-phase fault, and a two-phase earth fault. And we have single phase earth fault, unsymmetrical fault. We have three types, and one is phase to phase, and two phase earth, and a single phase earth fault. Now coming to the open circuit fault, we have a single open circuit fault, two-phase open circuit fault, and three-phase open. See the single phase open circuit. So one phase is opened, and the circuit fault. So open circuit fault. Here we have seen the two phase is opened with the open two-phase open circuit fault, and we have seen the three phases also open. This three-phase open circuit fault. So these are the open circuit fault. Now coming to the equipment and percentage of total fault, we have cause of the fault. Overhead lines, we have on a 50% of fault because of lightning strokes, earthquakes, sizing, birds, tree branches, night strings, and internal overvoltage. Because of this, major 50% faults may occur. So underground fault is 9% damage due to digging, insulation failures due to due to temperature rise, and faults of joining, and alternator stator for rotor faults. These are the main thing, measure of faults and what are the causes of faults. And transformer, because of the transformer, we have an insulation which is not properly insulated. No, during the tap changing and overloading, we'll be getting faults. The 10% of faults because of the transformer. And current transformer, potential transformer, there's a 12%. Current transformer is over voltages, and same thing as insulation failures and breaking of conductors and wrong connections. The connections, if there are connections wrong, again you'll be having the fault. And switch gears, finally to switch gears were 12% when insulation failures, leakage of oil, gases, mechanical defects, and lack of maintenance. The last thing is if the switch gear is not maintained properly, it may also causes the faults. These are the major faults. It's an unbalanced decomposition of unbalanced system. We'll be seeing the three phases in unbalanced. So we have because of this unbalance, we have seen the zero sequence phase, positive sequence balanced, and negative sequence balanced. We have all this sequence balanced. We'll be learning this in upcoming classes. And here mainly what happens is fault. So fault mitigating is improving the quality of machine equipments and installations by improving the design techniques, and adequate and reliability of protection control systems, and regular maintenance by training professionals, and effective management of electrical panels. So management is of electrical panel is also important. And last part is this, merits of fault clearing. So helps to avoid permanent damages of equipments, components of apparatus, and reduces the change of risk like fire hazards. It's an important thing. And maintain the continuity of the power supply and bring back the power system to the normal state sooner. This is the main thing of merits of fault clearing, fast fault clearing. And finally, we can wind up with this. We'll be having small summarize. We have nature of what are the nature of the faults. We have these nature of the faults. And what fault problems have occurs, and what are the major faults, and what are the protective principles, and these are the main thing. And we have in breaker choice, running relay running, system stability, and safety measurements. These are the thing. And with this, today we are going to wind up this class. We'll meet in your next topic. Thank you so much.